Welcome to this exploration of protons, one of the fundamental building blocks of all matter. Protons are positively charged particles found in the nucleus of every atom. Understanding protons is essential because they play a critical role in defining the identity and properties of all elements in the universe. Throughout this lesson, we will discover what protons are, their properties, and why they are so important to the structure of atoms. A proton is a subatomic particle that carries a positive electrical charge and is found in the nucleus of every atom. Protons are fundamental components of atomic structure, working alongside neutrons and electrons to form complete atoms. Each proton carries a charge of +1 elementary charge, which is equal in magnitude but opposite in sign to the charge of an electron. Protons are always located in the dense central nucleus of the atom, where they are tightly packed together with neutrons. The discovery of the proton was a gradual process that took several decades. In 1886, scientist Eugen Goldstein discovered canal rays, which were streams of positive particles. Then, in 1917, Ernest Rutherford conducted experiments that identified the hydrogen nucleus as a fundamental particle. Finally, in 1920, Rutherford gave this particle its name, the proton. The word proton comes from the Greek word meaning first, reflecting its fundamental role in atomic structure. Protons have several important physical properties that define their behavior. The mass of a proton is 1.6726 times 10 to the power of -27 kilograms, which is approximately 1 atomic mass unit. Protons carry a positive charge of +1.602 times 10 to the power of -19 coulombs, which is exactly equal and opposite to the charge of an electron. The size of a proton is incredibly small, with a diameter of approximately 0.84 femtometers. Importantly, protons are stable particles, meaning they do not decay or break down when they are isolated. Protons reside in the nucleus, which is located at the very center of the atom. Inside the nucleus, protons are tightly bound together with neutrons by an extremely powerful attractive force called the strong nuclear force. The nucleus itself is extremely dense and compact, occupying only a tiny fraction of the atom's total volume. Despite its small size, the nucleus contains 99.9% of the atom's total mass, with protons and neutrons contributing almost all of that mass. The number of protons in an atom's nucleus determines what element that atom represents. This number is called the atomic number, and it is unique for each element. For example, hydrogen has 1 proton, which gives it an atomic number of 1. Carbon has 6 protons, giving it an atomic number of 6. Oxygen contains 8 protons, so its atomic number is 8. No matter how many neutrons or electrons an atom has, it is the number of protons that defines its identity as a specific element. Protons are essential to the structure and behavior of matter for several reasons. First, protons define elements by determining their chemical identity and position on the periodic table. Second, protons create electrical balance in atoms by attracting negatively charged electrons, which can result in neutral atoms or charged ions. Third, protons contribute to nuclear stability by working together with neutrons to hold the nucleus together through the strong nuclear force. Finally, protons influence chemical behavior because they determine how atoms will bond and react with other atoms during chemical reactions. Let's review the most important concepts about protons. Protons are positively charged particles that are found in the nucleus at the center of every atom. They were discovered by Ernest Rutherford in the early 20th century through groundbreaking experiments. The number of protons in an atom defines the element's identity and determines its position on the periodic table. Protons provide atomic mass and contribute to nuclear stability by binding with neutrons in the nucleus. Understanding protons is essential for comprehending chemistry and the nature of matter itself. Thank you for joining this exploration of protons.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.